Welcome to another edition of DraftScience live. Anyway, welcome to another edition of DraftScience test. Yes, it does work. So I'm sort of interested in I've been watching Bill Gates videos for like I don't know 7 years. Um, I do watch other people's stuff, where they don't watch my stuff, which is sort of irritating. It's like the David D. Hilster guy. I mean, I'm sure I've watched many more hours of content by his father and him than he's watched hours of, me talking about my theory. So, I mean, it's kind of one-sided. And I'm sure the same is true with Bill Gates. He's I did attempt communication with him, got absolutely nowhere. He just preaches his rope theories, just kind of, you know, unapproachable in terms of having a discussion about, a better, a different mechanism for creating the tension in the universe. And that's all we're really talking about. I mean, all this ether stuff versus rope stuff versus particle stuff, all you're really trying to do is explain the pressure and the fact that we kind of know that matter is contained pressure because, when we do the nuclear thing, it has the obvious appearance of a release of pressure, just kind of obvious. So yeah, you have to have a system that has tension. It's wound up. So he does it with ropes. Twisting ropes pulls things together, untwisting ropes pulls things apart, kind of thing. But on its face, for me, it's kind of it's a non-starter kind of theory, just because the elemental bits, the train track, is more complicated than the train. And that's kind of a rule breaking kind of thing, that an evolution theory or a complexity theory, you can't have some place where you're going less and less and less and less complex, more elemental, and all of a sudden you get hugely more complex and you go back down again or something. It just doesn't make any sense. And so the idea of this twisting rope, the only thing it's really traveling on the twisting rope is photons, like the simplest thing in the universe. So the simplest thing in the universe needs a network of, I mean, he really believes this. He's really suggesting this, like, seriously, that every atom is connected to every other atom in the universe by a rope, and that the photons travel on the rope, just as a twist in the rope. And you're just like, that's an insane amount of infrastructure for something as simple as just a photon, something that goes from point A to point B in a straight line. And he mocks the idea of a rock. Oh, how could it be a particle? Can't throw particles and make something attract. Well, yeah, you can if you're throwing them on the other side. It'll make attraction. It'll also create pressure, and pressure is the whole thing of what the universe is about. So anyway, I'm going to just post this as a response and see if he deletes the comment on one of his videos. Because I'll just play some clips of his, and just to make the counter argument where he's mocking the idea of a particle being the function of the universe, when to me it's a perfectly sensible way of communicating. Throwing a rock with a note tied to it or something, throwing a bottle in the, a thing is a very good way to communicate. Morse code, dot, 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 dot. It's a very good way to communicate, throwing little rocks, little on and off pulses. Anyway, so with that in mind, I have to find the right videos here, because I have some time codes, but I have to have the right video. So I think this field one is the one we'll go to first. So I'll do this first, then I'll do comments, and then I have a sort of a breakthrough on gravity, something I just didn't, something very obvious that I should have recognized before. You know, quite interesting. You know, that'd be the word for it. Useful.
They also, and you can see how this is all circular, how they're terrible at defining all mathematicians. Field is a physics term for.
So these are, he's done a bunch of these conversations with his son, who's really quite intelligent also. And it's, you know, it's intelligent conversation. I really like the critique of conventional physics. It's a very good critique in most cases, very honest about how, you know, this theory they have is just so full of holes and empty answers, you know, just empty. They're not answers to any of the questions. They don't explain anything in any kind of physics way. So anyway, so this is, you know, so they're just having this conversation. The videos really aren't on the subject they say they're on, but, you know, it's close enough. So he did a few, you know, defining things like energy in a field and force. And yeah, he obviously doesn't have any use for most of these words, but obviously I would say they have perfectly good meaning if you understand that the field doesn't always exist. The field only exists when it's doing something.
Region, blah, 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 blah. That comes from the JPL, Jet Propulsion Laboratories paper called Basics of Radio Astronomy. This is the basics, and you tell the field is a region.
With Jet Propulsion Laboratory, these guys actually build rockets.
Uh-huh.
So these guys are actually doing like technology and basing like real people's lives.
But that's the point. The point is that technology has nothing to do with science, because you can be a total idiot in science and be able to work with magnets, you know, and say, oh, look, I can pick up iron filings. Look at the magic, you know.
Doesn't seem like this is the right clip, but we'll play a little more of it just because we're here.
And you say, well, yeah, but you haven't been able to explain how it does it.
Okay, but it's still kind of scary that people who are building rockets, you know, that's billions of dollars or whatever.
They don't need to know. They don't need to know the science of it.
But it's still kind of freaky that
they don't need to know causes. They just need to know effects. They need to know that hydrogen and oxygen do a certain thing. They don't need to know why they does the certain thing. So yeah, it's that kind of obvious. They just need to know a few of the rules. They don't need to know. Again, the causes aren't terribly important. Effects are terribly important if you want to use something. So when you're using something, knowing what the potential effects are is clearly more important than knowing why the mechanism creates those effects. I mean, knowing how bears evolved and why they have long claws and big teeth and this and that and the other, and why they're heavy and why their muscles are stronger in the front, and why their head is, you know, 1.5 inches thick. You know, knowing all of that isn't as useful as just knowing you can't hit them over the head. That won't work. Okay, you can punch them in the nose, but hitting them on the head will not work, you know, unless you have a cinder block. You know, or something, you know, even shooting them in the head might not work. You're better off trying to shoot them in the chest, you know, aim for their shoulder, a little left of their shoulder, right, and depending on the side, and you'll hit something more important by shooting them low than shooting them in the head, because the bullet might just bounce off their fucking skull. I mean, knowing those facts is more important than knowing why do bears have thick skulls.
Regions of space and kind of talking these weird abstracts.
It's all like that, and that's what's so weird. That's what's so dangerous, that these people are just you know, juggling concepts. And here's the circular part of that. If you look up the word, okay, so field is a region of space. If you look up the word region, it's a portion of space. And what is space? The infinite extension of field. so we made full.
Yes. So as I would argue also, that it's just babble. It doesn't mean anything because their field doesn't have a substance in it. So it's a field of nothing is nothing. You know, 10 fields of nothing is just more nothing. It's nothing. All right, so this is obviously not the right clip. So we'll go back one more and see if maybe this was the clip that the time code was relevant to. We'll see. Can't hurt much. He does this 2 minutes in the beginning where the video doesn't play for whatever, he does a countdown thing. It's kind of not a very good intro to a video.
And here I have it.
Here we go. I think this is it.
It's the quantum dilemma. Okay, and what is the quantum dilemma? It says that, how does a particle pull on another particle?
So, again, the obvious answer is we are talking about two things moving together, two things moving apart. So obviously, if I want them to move together, I put particles on the outside. And the particles on the outside are doing the work, and the ones on the inside have less particles. So if I reduce the pressure on the inside, fewer particles, and I have more particles on the other side, then I have attraction. And there's no real example of he's claiming that somehow physics is saying, see, he thinks their model is a particle model, which is the huge joke, right? Because obviously it's not a particle model. Conventional physics doesn't have a particle model. They think they're all Heisenbergian wave functions. They don't see them as objects. Clearly, their drawing of a photon has nothing to do with a frickin' particle, so it'd be idiotic to say two waves going this way and this way are a particle. That would be retarded. So, it's sort of ironic that he's arguing that their theory is a particle theory. My theory is a particle theory. So if you want to argue particles, argue with me, because I'm the one with the particle theory. So he'll have no example. So he makes this example. Well, how can you throw a tennis ball at something and it'll move towards you? Well, there's no example of that, right? We have no evidence of forces being pushed at something and it moving towards us. And the only example we have is gravity. And the argument is the thing is blocking the gravity. It's obviously less forces getting to the thing. Fewer tennis balls are hitting it. And so more are hitting it from the outside. But so, it just seems like such an empty argument to say pull is somehow a rational event and push isn't. When obviously push is an incredibly reasonable function and pull is how do I make a puller? And so the only way he can make a puller is he ties a rope to every single atom in the universe, going to every other single atom in the universe, which is an insane number of ropes. I don't even know how you could calculate the insane number of ropes. It's an insane number of ropes. And somehow that's more viable than the story I just told, which is, no, there's particles pushing from the outside all the time. And the real game is if you run out of particles on the inside and there's more particles on the outside, you lose some tennis balls on the inside, they escape. Well, then you got less pressure on the inside and stuff ends up moving closer and closer to each other. Seems way more rational. Way more. And, I feel sort of bad because, Bill was actually sort of relevant, a few years ago. And, 8 views. This video has been up for 2 days. 8 views. It's horrible numbers. And these conversations, in my opinion, deserve a lot better than that. Because even though Bill's theory, in my opinion, is shit, his analysis on many of these subjects is not shit. It's very informed analysis. A lot of it's really good. The philosophical elements of it in terms of the big picture way of looking at things, even his analogies are very good. He's very personable. It's all very genuine and honest. It deserves a lot more than 8 views. These conversations between him and his son are really the way conversations should take place. This is kind of stuff that should be, in all the sciences, these kinds of open-minded, kinetic, real-time, brain engaging conversations are what should be taking place.
throwing particles at it, throwing stones at it. And that's the big quantum dilemma. And unless you can answer.
Yeah, so frankly, it's not a quantum dilemma because they gave up on particles 100 years ago. So this is, it's such a straw man to say that conventional physics is a particle theory. It's just a straw man.
Answer that question. Quantum dies a sudden death. It has no chance whatsoever.
So again, and quantum is another concept. So quantum can exist as a concept separate from particle wave. You can quantize a wave, you can quantize an amount of wave, and you can quantize, obviously, particles are much easier to quantize. But clearly it would be how you would quantize them. And clearly, even if I was to say, even if I got them to concede that photons were a real object, they would still probably perceive them as objects that themselves were the frequency. So they still wouldn't think of the quanta as being individual bits, and that a photon was really always had to be at least two of these little bits of quanta. Because they're thinking of it as, I make this bigger or longer or shorter, and that'll be my photon. That the photon is the solid part, when, that the frequency is the solid part, when the frequency is the space between the solid parts, in my opinion, clearly.
Science, because what quantum will never be able to explain is the force of pull. It cannot explain the gluon, as I showed a couple.
Yeah, well, the gluon is nonsense. Obviously, silly word, silly concept, silly rubbish. So yes, not an explanation for anything. Clearly, it's pressure and lack of pressure, and that's the system. That's the mechanism. So you're either getting hit by the radiation or you're getting not hit by radiation, and you move based on how much force is hitting you in a particular direction. So when the space shuttle engine is firing behind you, the equal but opposite reaction takes place, and essentially a bunch of force equal to that flame is ending up going through you, and you're collecting it. You're starting to accelerate. Fact.
Weeks ago, also when we went into mass, the gluons cannot pull two quarks together by how would they do it? If the quark throws stones at the other quark, how does it pull it?
Well, I don't know if quarks would actually do that. I don't think they have a mass or they're charged. So, but whatever. Let's say they do have they convert field energy. So energy goes into them. They do something to the energy, meaning they filter it in some way, causing their charge, because that's what an electron is doing, and that's what a proton is doing. The force goes into them, and frankly, the force reflects. One force reflects off of them, and one force is 90-degree turn. And so clearly that creates an object that has that doesn't have to do anything mechanically beyond just this turning bit and the reflection bit. So all the black reflects, and some other force leaves in some other direction. So it can't get caught in traps. It can't bounce back and forth. If it leaves in the wrong direction, it's free. And so the two become charge elements. It's just, to me, plainly obvious that's the correct answer. That explains charge so perfectly. And it explains why pressure is the whole game. If you find a way to let the pressure out, then you have a low pressure. The two things can move into each other. If you reduce the number of reflections happening, yes, the outside pressure pushes everything together. The whole universe looks like outside pressure has pushed everything into little balls. And that's what outside pressure would do, is make little round balls. That's exactly what an external pressure would do. It all fits perfectly, well, excellently. The simplistic argument that somewhere a particle theory would suggest that I throw something at something and it is attracted, nobody's suggesting that, beyond suggesting that maybe if this is a proton force and I throw it at an electron, that the force is going out. It's not coming back at me. And that'll be pretty important. And then if it's a certain kind of force, yes, I throw it and it bounces back and it bounces back and it bounces back. And that clearly explains repulsion, which your rope theory has a little bit of trouble with, because now for repulsion, I can just make the joke, like pushing on a rope. Ropes really aren't going to work for doing the pushing thing, are they? I don't think so.
And this is the issue here. That's the quantum dilemma. And that's why quantum cannot answer issues such as entanglement.
This really isn't. Well, there is no entanglement, so that's just silly anyway. But they answer plenty of questions, but their answers are so vague anyway, it doesn't matter. So they just say virtual this and virtual force and bent space. And so they come up with these very God of the gaps kind of theories that require that from their perspective are immune to any critique, because they have no details. You can't criticize them because they have no shape, they have no substance, they have no reality, they produce no odor, so you have no capacity to say they smell. Where if you have a real theory, well, then you're subject to these critiques because it has real consequences. It's a real thing in the real universe and you have to account for it. Where their magical God solution is completely separate from accountability. I can't pick at it because it's entirely a fantasy. It has no reality and has no consequences to reality except for the one thing it does. So it has a magic wand. It does magic wanding. I can't critique it because the magic wand factory is in the same place as the person using it. It doesn't have any reality.
EPR and so on. All these observations, experiments, etc., phenomena, you can't mediate them with particles and produce the force of pull.
Again, there is no force of pull, so there is no pull. Pull is a not smart concept. It has no hope as a concept, really. When you really think about it, it just has no hope unless you do something like you're doing, which is you prearrange to hook everything to everything with rubber bands. But that's essentially the only way you can create pull. There's no way to make it any other way. You can't construct it any other way. There's no way. It's a push universe. There just isn't any such thing as a true attraction. Things are getting free from something. It's just like us. We're running from poverty, not running towards wealth, kind of a thing. It's always the negative that has the power. We're looking to be relieved from negatives. The positives don't even have to exist. All we want is not to be in the negative condition.
And you cheat and just throw.
And that's what they do.
Baseball bat.
And that's what they do. They cheat. One of the guys that cheated was Yukawa, and I think he got a Nobel for this. He came up with the strong nuclear force between two neutrons in a nucleus is described roughly by the Yukawa potential energy. And what I like about this whole thing,
well, probably no point in getting into this, but he likes the negative number. And again, I would argue that the reason the strong force is being created by a mitigating electron, that's part of the neutron. So without the neutron, the two protons can't possibly get close together. But because of that mitigating electron, that's where all the force exits. And then the protons move right into the low pressure. So as long as you remove the proton force through the electron, no problem. So anyway, next. Next would be the charge video, I think. All right, charge. And we should have something interesting at 34 minutes. Yeah, see, he does this at the beginning of the video. It's 2 minutes of nothing, which just doesn't, it seems you ought to fix that. Not a good idea, I don't think.
In a very simple way to a kindergartner, he'll understand that. But don't tell me, don't tell someone out there that that's what Mother Nature actually has out there. And again, we have a problem with.
Let's go back a little.
Get an idea of what quantities they're working with. So in that sense, it does help. This is good. So nothing wrong with the experiment at all.
Yeah, I can't remember whose experiment this is. The oil drops going through a hole in two charged plates, and then they ionize the oil drops, and that way they can essentially levitate the oil drops through using the charge, just to demonstrate how much energy it takes to overcome the force of gravity, which basically tells you how much the one electron has as a charge value because you've ejected it. So now you know how much charge potential that's changed the atom, and therefore you can tell how heavy electrons are. Kind of a sneaky way. Well, how charged electrons are.
What is the rope model because one thing that Millikan could not explain, and to this day no one can explain in quantum mechanics, is what do you mean you're removing an electron? And we all understand that as saying, okay, if I
so he talks a lot about this Compton, and then he gets into so the other experiment. Well, it doesn't. So yeah, it's a lot of interesting stuff. I forgot the gist.
Remove an electron, right, from an atom. It changes the.
Oh yeah, what an electron is. So clearly, I think it's pretty logical that electrons are removed from atoms that creates ions, and when the electron's free, it's creating pressure. By just existing. So it's when it's in the atom, it's in pressure, but when it's outside the atom, it's also pressure, because now it's an element of congestion. If it has any momentum, it's obviously creating pressure in the sense that it's hitting other electrons and other atoms. And that pressure can be interpreted as voltage ultimately. So the more crap you push into something, the more you increase its potential voltage, essentially. But it's mostly just an electron force. So voltage is electron force, and it's conveyed through electrons.
Characteristics. But what are we removing? Well, we're removing a little bead. That's the official version. We have the proton, and we're just going to deal with the hydrogen atom just for the sake of argument here. We have the proton in the center and the electron bead running around it, outside of it. And what happens? If you remove the electron bead, somehow this thing has a positive charge, what's left.
Yes, and it seems quite logical that that if you understand the two charges, and clearly by my theory, it makes perfectly good sense because now you've taken some of the pressure out of the electron, and now there's less compensating for the positive charge of the proton. There's obviously fewer charge mass. There's less charge mass creating a shell around that positive charge. So more of that positive charge leaks out. It's stronger than the negative charge. So if I bring something to something and has 4 electrons, I'm going to start encountering these electrons before this because of the inverse square law. So the positive core is not going to be as relevant once I get close to these electrons. But if I take away one of these electrons, then I'm obviously going to be less close to an electron. And so the charge of the total atom will be more positive because I've removed the negatives, a piece of the negative. So that seems pretty logical to me.
It's a positive ion. And the electron has the negative charge. It was taken away. That's how it's explained. Everybody understands that because it's a very straightforward explanation. It's a kindergarten stuff that anybody can understand. What we can't understand is what kept the electron tied to the proton in the first place.
Yeah, and that's the external pressure, once again, and the fact that the two elements, the electron and the proton, their opposite charge essentially means is the black force reflects off the electron and it doesn't reflect off the proton. It goes out perpendicular. And the red force bounces off the proton, but it doesn't bounce off the electron. It goes out perpendicular. So you have escape valves. That essentially means the external pressure will be greater than the internal pressure. More ping pong balls outside hitting it less ping pong balls in between that are going back and forth, the two things want to move towards each other. Now, the other factor is the electrons are also reflecting. And so their ping pong balls are constantly going back and forth, which means they have constant pressure saying, I don't like it, forcing them apart. So you can't move one electron in without shortening the pressure distance between these two electrons. So you can understand if there was 3 electrons, one here, one here, one here, like a hexagon. You can't move this one down without shortening the distance to the other 2 electrons, which means more pressure. So there's always pressure holding the electrons in a circumference. They can't go in because of the repulsive force between the other electrons. That's how you explain it. Quite reasonably, I would argue.
That's where we run into trouble. In other words, the model of the atom, this planetary model, is what's wrong. That's okay to explain ionization in a very simple way to a kindergartner. He'll understand that. But don't.
Yes, I think the solar system model is okay, but it just has to be understood that all these little pieces on the outside don't need to be going horrendous speeds. There's no need to spin everything. They can just jiggle in place, and that satisfies all of the functions. There's no need for everything to be rotating and to have a whole bunch of momentum.
Tell me, don't tell someone out there that that's what Mother Nature actually has out there. And again, we have a problem with the structures, the architectures that quantum mechanics proposes. What is the architecture of the rope model? Well, it's a little more difficult. It's made of balloons. And here I found the best analogy for how you're supposed to look at this from the rope model. And here what you have essentially is, the S shell and the P shells. That's what they somewhat would look like. The P shells would be in orthogonal to each other. That's the way you're supposed to think of it. Here I just took a flower made of balloons, right? Just to make the point.
So clearly, this doesn't seem to be the right clip either, but we'll play a little bit more, but it seems obvious it's not the right clip.
Just to explain how we look at this thing. And what we have here is that if you remove one of those balloons, you pop one of the balloons, what you have is an ion. Okay? That's what, under the rope model, what you would consider ionization. One of the balloons disinflated for whatever reason.
Ah, that's so funny. I never had a cramp in my middle finger before. That was just hilarious. My middle finger cramped. That was just so opportune. Anyway, so this seems like the wrong clip. So we'll just move on to 44 minutes, I believe. So yes, I have to take better notes. There's just no excuse for these poor notes I take. Should get this right, what video I'm watching when I take the damn note. 44 should work.
Gravity, gravity, I do it with the ropes, and you can see how the objects approach each other and the ropes fan out. You get the idea of the mechanism. Whether you believe it or not is irrelevant. I mean, that's the
okay. Yeah, well, no, you really don't get the idea when you tie these ropes. I could understand a few ropes, like 7 ropes between the Earth and the sun or something. But a rope from every atom to every other atom in the entire universe. And I think he thinks it's every electron to every. I mean, it just can't be that way. Again, it's like having the train on a track that is, many times more complicated than the train. It just doesn't make any sense. It's like having trains carrying trains. Or putting a train on a plane. It just doesn't make any sense, right? No one would buy a plane ticket.
Mechanism I propose, and all I want you to do is to understand my mechanism.
So you show the quantum gravity with throwing the ball that pulls you.
Yeah, how did that
look at you like, I've never seen.
Okay, so again, so he's laughing at the idea of throwing a ball and making a traction. And again, the argument, it wouldn't be that you throw a ball to make a traction. The idea is that you're throwing a ball at the back of somebody's head. And that when you do that, you know, when he's talking to Sally or something, it's going to look like a traction when he, you know, when his head moves and he kisses her because you threw a ball at the back of his head. I mean, it's going to look like a traction, but it's not a traction.
The ball pulling you forward. I've never seen that before.
Let me try it at the lab. It never comes back unless it's a rubber ball bounces against the wall.
That's a good.
The ball comes back, but not the wall.
Yeah. So I mean, again, it's like, yeah, but this whole idea of a pull thing requires you. Like I said, the only way you could make pull. I mean, they made pull by just creating God and say God pulls. So God is in the middle of the earth and he's in the middle of the sun and he's pulling the earth towards, you know, because he's eating space. You know, he's a space eater and he shoots the space out his ass into the fifth dimension or something. And so he can just keep eating space and the earth knows the space. Hey, a bunch of empty space disappeared. I better go there because there's an absence of empty space. So I better move into the empty space that's gone because it's emptier. You know, when you remove space, you end up with a hole in the nothing. And, you know, the nothing hole is quite obviously more nothing than when the nothing was there. So more nothing is obviously more nothing. You know, a hole in nothing is obviously a bigger problem than just nothing. Obviously a silly explanation, but I would argue that this idea of just tying everything together and saying, okay, there's my pull. I glued my hand, okay, to the bottle and now I can pull it because I glued my hand to it. I mean, yeah, duh. But that's not much of an explanation, frankly.
Pull on the wall.
The illiterate deaf mute person is the perfect, template for a real person to
understand physics.
Yes.
Yeah, right.
Right. So the deaf mute would understand what pressure is, right? I could create a circumstance where they're getting like water pressure or some other thing where you can feel it. You can feel the pressure. So I can make that understood that if I move this way, it's because a wind blew me that way. That could be understood. That I wasn't attracted to the falling over the cliff. Okay, it might look like, I love you, empty rocks and stuff I'm going to fall on. You know, the wind blew me off the cliff. I wasn't attracted. Nobody threw wind at me this way and that pulled me in. No, wind hit me from the other side and pushed me in because there was a lack of wind over here, a lack of things thrown at me. Again, I could just take a bowling pin and you could throw tennis balls at it and you can get the idea that if I throw more from one side than I do the other side, it'll tip over. So if we concede that we already know that this pressure exists, the cosmic background radiation is evidence that there's a constant pressure, and all we need to do is give that pressure a little more bulk based on the fact that we're not seeing the gravity, because you can't tune it in on the radio. You can't tune gravity in on the radio. But it's there as a force, just like the radio waves, just like the photons. All right. So I don't think this conversation really goes anywhere further.
You're using balls to pull things. That guy look at you like, that doesn't happen. I've never seen it happen.
Yeah, and if you put equations on it.
So again, no, this is sort of a straw man argument because obviously quantum mechanics doesn't do that. It doesn't use balls to create negative forces, generally speaking. There's some kind of deer in the backyard. Don't know if I really have to go look, but I probably should. So, you know, they ate the shit out of my stuff. So, you know, yeah, problem. All right, I'll be back. Ugh. Okay. Yeah, I know. Deer netting just isn't enough anymore. So, I have to go and I have to monitor the beasties. They like half my plants the other day. It's just like you spend months doing all this stuff. Get little plants, they just show up and nail it. Just wipe it all out. Because we as a civilization can't figure out that, gee, this is costing billions of dollars and people's cars are getting crashed into and all this expense and the deer's only living an average of 3 years. Obviously, we need a better solution than to give the job to hunters who enjoy killing things and want more deer so they're easier to kill. Yeah, you don't let hunters fix the problem. Wrong solution. Bad theory.
He's gonna say, okay, yeah, perfectly. So here's a little C and here's a little V. What all these? What is this all alphabet soup?
He's illiterate.
No. But assuming he's literate, let's even concede that he's literate. He looks at these. I just see little letters there: C, V, A, B, X. Well, what is this?
Right. So we don't need all this stuff. It's just rag on quantum mechanics, which I agree is nonsense. But it's also rope theory is going to confuse the fuck out of anybody because you're going to say, how do all the ropes not get tangled? I mean, it's just ludicrous. It's more than ludicrous. I'm just saying, I don't even know how do you even argue a theory that's this. Every single atom is tied to every other atom by 2 rails. And so it's like a single rope. No, it's 2 ropes for each atom, to each atom. I don't even know. Come on. That's not stretching reasonableness. I think it's stretching it. All right, anyway. So I think this is the last one. What did I do with that piece of paper, actually? That's my notes on it. All right, 340, I think that says. So I think this is the photoelectric effect. And we'll go to 3 minutes.
Spinning of the electron
3
shell.
minutes and 40.
What
Somewhere
we
around
have
here.
is the
Let's go there. That's close enough.
For this kind of thing. Anyways, we started the week with slit experiment, more or less. We're looking at the properties of light. And I continued with...
he does 4 of these a week, hour-long conversations with his son. So again, it's really very good effort, but quite watchable, mostly. But yeah, he does seem to drift off the subjects a bit.
With Compton scattering, Compton effect. And today I just like to cover a little bit of the photoelectric effect, which is pretty much...
How did we get to 4? I meant 3. I need 3 something. 340. So I gotta go to 330. I don't know. Something was wrong there.
Like the Compton effect.
Come on, back up.
Except that it
won't back up. All right, we just started here. Whatever here is.
Are just improvised completely.
But we're getting better at improvising.
Oh, it's already too far. Jesus Christ. All right. Try again.
We're still trying to adjust our schedule to find out what fits better, what is more efficient, I guess.
I also think we're getting better at doing these podcasts in general. We started off more choppy, more amateur. We're getting better at it.
Yeah, that's one thing. The other thing is, we do a lot of improvisation here. All of it is improvisation, essentially. I do have some gifts that I use.
Yes. So they're talking about the fact, they're getting better at, and I agree they had some technical crap in the beginning, blah, blah, blah. But the conversations, like I said, they do have a very good rapport in terms of the son is, he has some hard questions. He doesn't throw softballs all the time. All right, so it's 8 minutes. Sorry, my mistake. All right, so now he's talking about the double slit. This is supposed to be the photoelectric effect, but he's talking about the fact that he does it with a needle. Now, the interesting thing, something I didn't know, he doesn't apparently know about Newton's rings, which I thought was funny. But he does know that about Newton's hair. So apparently Newton took one of his hairs and did and saw this pattern, same with a needle. So he already had done the single impediment experiment, which makes Young's experiment even less interesting. In hindsight, it's just Newton already did it with his hair. So what's so remarkable? Because the Young experiment really didn't have the idea of the double slit inside the single slit envelope. None of that was part of Young's mush. So, I mean, it really becomes the fact that people keep using Young as if he did something remarkable is just hilarious in the real context that Newton already had done it with a hair. So, but the needle experiment doesn't duplicate the double slit. It duplicates the single slit. That's why the center is so bright. It's duplicating the single slit.
Is that they can bounce off of the edges of the outer edges of the window,
Of the frame.
of the window frames.
Right, and what we're saying here, you don't need those edges of the window frame. You can just
all right, now nobody made that argument. I mean, obviously when Einstein and those other guys, Bohr and the rest of them, were talking about this double slit thing, there was some talk about that and how that's not really going to be an issue, that you can't account for this pattern based on reflections off of surfaces. It just doesn't have anything to do with it.
put a needle, and now there's nothing to bounce against. And if you're still producing, fringes, then there's got to be a different explanation for them. Especially, you got to use a different model for light. You can't use particles because the particles should go straight ahead.
Right. So I guess that was probably what I wanted it for. But obviously they don't go straight ahead. Obviously a particle can be deflected. I mean, it can hit a surface and be deflected. We can know lots of things can deflect things. And the argument is electrons and atoms aren't smooth surfaces like this. So the deflections are going to be quantized. That is, they're going to be interactions with things under specific pressure, each one of the objects, and that pressure is what's going to decide the angle of the reflection. So it's not the same as it hitting some kind of round surface. The roundness isn't a reality. The pressure of the electrons is the reality, and each electron's under the same pressure. So there could be a very common experience for each one of those encounters in terms of these deflections will be by a specific quantizable amount. Nothing unexplainable. I mean, it's a little bit, I mean, again, he's sort of guilty of the same crime as the others in terms of making these very weak arguments, like Feynman's argument. Well, more rain hits you when you're walking into the rain, and then from behind if you're running in the rain. And, they're just simple generalizations, and you say, yes, but there could be a reason why that doesn't apply. And clearly there's a reason to understand that the reaction between photons and electrons doesn't have anything to do with straight things going in straight lines. It's covered with the idea that there are reflections, perpendicular reflections, which could cause U-turns, pretty obviously. U-turn. U-turn. That kind of thing.
And I showed a picture of that last week. Here I'm just trying to summarize. I'm just going to say that this is my version of it. The ropes from every atom in the universe are interconnected. We start with that assumption.
Okay, so just imagine every atom in the universe has ropes going to every other atom, and the photons are traveling along those ropes as twists in the ropes. Now, this doesn't explain anything because it doesn't really explain how, by his theory, he's saying light actually goes to the dark spot in a sense, because he's saying the two ropes are out of phase, and those ropes would have real energy on them. They're real twists. So it's a real photon that was destroyed. So in a sense, it doesn't make any sense. because the two twists means real energy went along those ropes. How do you account for the energy? And he doesn't account for it.
And we're saying that the atoms that form the laser pointer or whatever light source you use are already connected to the atoms of the needle before you start the experiment. Every atom is connected to every other atom with.
Right. And again, every other atom would be every other atom of the needle, which is a preposterous number of atoms. I mean, an insane number of atoms. And, so I send a single photon in somehow along one of these for, trillions of threads. The one photon travels on these trillions of threads somehow, and somehow it's going to go out here instead of attempt to go into the needle or something like that. Doesn't make much sense, really. All right, anyway, so that's enough, I think, of the Bill Gatey part of the conversation. So, like I said, I'd like to borrow his son, frankly, if I could. See if I can convince him of a few things. Be a nice test. I think he's an honest sort. And so we'll see if I can provoke Bill into some kind of interaction. I mean, it really can't hurt in the sense he's getting 11 views on this video. Now, I think I can make those view numbers better than 11 if he lets me. So just for that alone, he should be willing. But anyway, we'll see what happens. All right. We're both doomers, too. I mean, he's actually pretty much thinks the human race is a pile of shit and deserves to be squished. So, we agree on a couple of different subjects. Yes, they're wrong, but his answer is not the right answer. All right. So I don't think there's anything else of, I'm getting behind on the relativity videos again. I gotta catch up. Don't think I'll bother with the Hilster this time. Butt heads. Anyway. So we got some comments. Might as well do that. We'll see if there's any live persons that have anything reasonable to say. Are you saying that the claims made by quantum physicists are unfalsifiable? It doesn't matter. I really don't have any use for this term, unfalsifiable. I only really have the real point is that when you have a theory that's a UFO theory or a God theory, and you pretend that we don't have cameras and we can't have evidence, and clearly a God of the gaps, in my opinion, says it all. If it's a God of the gap explanation, that is, you're just basically saying you can't explain, therefore you'll invent some explanation that can't be touched, that can't be analyzed or scrutinized because it has as its premise invisibility. So, but there's nothing wrong with having something that's untestable as a theory on its face. I'm just saying when you're doing it as a resort because you can't find a better answer, then that's just horseshit. I'm just saying you can logically infer things from evidence without having direct evidence. So I just don't like the word unfalsifiable. I don't think it's very useful. When you made that magic wand analogy, well, all the analogies I think are suitable. I'm just saying bent space doesn't give you any explanation for anything. It explains nothing. It's basically just creating a secret mechanism, an invisible vacuum cleaner that vacuums geometry. It's just, I can make up anything, right? Now, if I just say it's a mundane force, a mundane mechanism. Now, if I was stupid, I could say, I think it's Barney the dinosaur, and he's hungry and he eats space, and that's what does it. Now, you could say to me, yeah, that's bullshit. I mean, obviously, you're using a cartoon character and you're making him invisible and you're putting him in the middle of the nuclear sun. That doesn't make any sense. Barney the dinosaur can't live inside the sun. So you could obviously falsify that because I gave you too much information. But if I give you even less information, I say it's an unknown entity of unknown powers and function that does this thing as a side job. Yes, it has other jobs, but this is what it does as a side job: is it consumes space and makes planets come toward it. Yeah, it's just, yes, frankly, that's unfalsifiable. I can't prove there's no fake entity inside the sun eating space. Yeah, I can't prove there isn't any beyond just saying that explanation is vacuous. It has no evidence pointing towards it. There's no evidence at all, no material evidence, no physical evidence demonstrating that thing exists. There's just this consequence, and you're just blaming that thing. And it's no better than me walking into a courtroom after I've killed my wife and saying, prove the invisible man didn't do it. It's no better than that. Saying I'm innocent because the invisible man did it. Now prove that theory wrong. You know, that's bullshit. Yes, of course he had my fingerprints. Yes, he stole them. It's easy to steal fingerprints. Yes, he stole my DNA. Yes, that's invisible man can do that. You know, he can just sneak up on you and steal your jizz. He can do anything. So of course he did it. I mean, it's just not plausible nonsense. It's nonsense. It's not a stupid argument. All right. These people are stupid. Let's see. Did you just attempt qualify a quantity? Is that a real tinfoil hat you're wearing? EMESCO. How retarded are you? Well, we'll find out shortly, I no doubt. After entertaining partial wave duality, okay, who's doing that? Theora Apopoulos ideology and your demonstration of his ideologies leads me closer to subscribing to Theora Apopoulos. That's where you belong, frankly. Idiots belong in idiocracy. Okay, I would posit that we gave the thumber uppers on Theora's videos IQ tests, they would fall in the lowest quintile. They're imbeciles, fucking idiotic, daydreaming, pot smoking imbeciles. Okay, because he says nothing. He explains nothing. There's no explanations. Magnets attract because they attract. There, that's all he says. There's no mechanism. There's no explanation of how that happens. Nothing. Just garbage. And you fall for it. You're a fucking idiot. Oh, amazing. Makes perfect logical sense. By the way, YouTube unsubscribed me from this channel. Mike Adams created a new alternative to YouTube. Oh, how exciting. You should really put videos there so nobody can see them. Oh, yeah, that's a great idea. Who the fuck's Mike Adams? Really quite irrelevant, so we'll just delete that. Now we know why Nibiru has 4K year cycle. I don't know what that even means. Fuck you, I guess. And this video explains it. No, my video did not explain anything about any kind of Nibiru. Seems you and Tesla are 100% correct. Well, obviously, you're a lunatic. Because obviously, Tesla and me agree about nothing. Yeah, pretty much absolutely nothing. Yeah. All right. Have you checked out this manga guide to relativity? Question mark. Haha. Funny, funny. No, I'm really not interested. Sorry. I'm really doing physics here. I'm not doing whatever your animation fun things. No, not doing that. Shit. I'm sorry, Gary, but here is what you don't understand. Yeah, fuck you. Here's what you don't understand. You have your fucking pompous douchebag head up way up your fucking ass. Let's go find out who this Lucas is. Lucas fishing man or something. What is this picture? What are you, some sort of... I'm lost in 1742. I long to be a homo cowboy on the range, doing some butt fucking. What the fuck are you? You have no content, no subscribers, and you're giving advice. I give you some advice. Get an identity before you show up like you have an important opinion. How do I qualify your fucking opinion, douchebag? You just show up somewhere and start telling people like you're a professional pilot, are you? What are you? You give advice to everybody? Fuck you. Fuck you. Okay. This is a quote from Lawrence Krauss, a lunatic. So arguing that it doesn't make sense to you is based on the assumption that you know what is sensible in advance. How does this have anything to do with anything? I'm giving arguments, explanations, arguments, illustrations, drawings. I'm giving you tons of details to pick up to pieces about the fundamental mechanism and how it works. All right. They give you nothing. They give you virtual photons, black energy, black holes, black, dark, invisible this, invisible that, the magical bent geometry, whatever the fuck that is. And you're sitting there giving me this crap. Fuck you. We don't know what is sensible in advance. I mean, again, it's rational and logical consistency with evidence. Again, I can make this argument over and over again. It's not that complicated. Do you understand when I say something like, imagine pushes? They're all really simple. They're one thing forcing itself on another thing, right? Pretty obvious, not complicated at all. Push. Now, why don't you explain how physics, the mechanical world, makes a push? Why don't you explain how the push happens? The pull without a push, without the push first, without the push creating pressure. How can you pull something out and have the other stuff flow in? Doesn't it have to have pressure? Retard. All right. Until we explore the world around us, our common sense derives from the fact that we evolve on the savanna of Africa. Oh, this has something to do with physics. Evolving on the savanna of Africa has something to do with the fact that they can make up a God of the gap explanation and say, there, we're done. The force is just magic, okay? Magic bent space, magic virtual photon. We don't have to account where the energy comes from. So two of the most obvious energetic events in the universe, planets hurling towards the center of suns, and galaxies, and galaxies probably aren't getting smaller. But anyway, and magnets smashing into each other and really hard to pull apart and repelling, just flipping them over, and they repel with just an equal amount of force. No explanation for where the energy came from. None. Zero. And that has something to do with the fact that you grew up in Africa, huh? No. That's a bullshit excuse. That is a fucking red herring. That's a trip to like Walmart. You're just pretending to be doing something reasonable. To avoid lions. Okay, so this is just amazing crap. Not to understand quantum mechanics, for example. I don't know what this is. As I have often said, common sense deductions might suggest that you cannot be in two places at once. Yes, that's right. It's just silly crap. And frankly, it's an extraordinary claim. And it's okay. You want to make an extraordinary claim? Fine. At least produce ordinary evidence. They haven't even produced ordinary evidence that anything was ever in two places at once. They haven't even produced ordinary evidence, let alone extraordinary evidence. Okay, that is crazy, but if it's crazy it's faith to believe without evidence. They don't have evidence for any of this crap. It just conveniently creates invisible men that they can blame for everything. So instead of blaming their eyesight, they're blaming the text on the page. Okay, their eyes aren't making the world blurry. No, the world is actually blurry. Isn't that just an obvious cop-out? Isn't that obvious scapegoating? We're not smart enough or diligent enough or hardworking enough to go out and find the right answer. Okay, so we'll just blame something obvious. We'll just blame the car. You know what I'm saying? The car crashes. Oh, well, yes, of course, I was on my cell phone eating a Big Mac, watching TV. Yeah, that didn't cause the car to crash. No, it's the fucking car did it. I mean, isn't this obvious scapegoating? But of course, not only can the electron be, but it is. So they assert it is, and yet their evidence is incredibly weak. Tiny shreds of little bullshit. Not even close to anything like a videotape, not even close to like a fucking leg bone. They have nothing. Their evidence is vapor. And here they say, but it is. No, but it isn't. Jesus. It doesn't make sense because we didn't evolve to know about it. Oh, amazing. So again, scapegoating. Our brains aren't capable of understanding the universe because the universe is so special. You might as well just be doing rope theory, right? They might as well just suggest every atom is connected to every other atom with fucking strings, right? That's what string theory is basically doing too. And it's all a beautiful symphony. And la 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 la. This is such fucking baby talk. Oh, damn it. You're not humiliated to write this shit? It's amazing. We've learned about it. We've forced our ideas of common sense to change. It's called learning. Amazing. You learn by becoming babies, going goo, 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 unicorn, unicorn, unicorn. This is baby talk. You're fucking infants. You're being duped by a garbage. You're not even being duped by an interesting lie. I mean, this is a preposterously stupid lie. It's like the Trump lie, right? I didn't say cash. I said, we're not going to pay in cash, right? No. I mean, you people are just insanely fucking dishonest to think this is an impressive pile of mush. This is garbage. All right, so somebody decided to point out, I think, hopefully, that Lucas is a douche. I'm sorry, but I don't know what you just asserted. We do know that we don't know. We do know that we don't know. We know a ton. I mean, so this is another one of these cop-outs. We know so fucking much. We've done so many fucking experiments. And the truth is they don't want the mechanical truth. They don't want to do physics. They want to do magic. Or you know and Larry knows, but. Or you know and Larry knows. I don't know who Larry is. I'm Gary, by the way. Oh, my turtle says he thinks he knows and agrees with Gary. This isn't much of a useful comment either. We both might agree that this and your comment was a waste of time. High five. Yes, your comment seems to be a waste of time also, unfortunately. Yeah, Uda said this. You don't address anything in the quote. Well, what is there to address in the quote? We're too stupid because we're just dumb animals who grew up on a plain that had trees and flatland and water and crocodiles, and we had to figure out how to navigate that world rationally and how to economize and be efficient and all of that crap. And somehow that has nothing to do with physics. All of that rational understanding that I can't jump into the tree, I have to climb into the tree. All of that rational stuff somehow has no applicability to reality. Reality doesn't have anything to do with up and down and the gravity you feel on the savannah and how hot it is, right? And the thermal problem. No. It doesn't have anything to do with no understanding the universe, because the universe is somehow upside down and wacky and all full of playing cards with arms and legs and rabbits with watches and blah, 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 all Alice in Wonderland little baby bullshit. God, you people are just so fucking disappointing. I should be able to just get rid of it all by getting rid of the one comment, right? Yes, hide this fucker. Pile of crap. All right, the traps theory thing. Yes, traps, very interesting idea. Force, no force. Force, no force. If the bad guys, right? There's a bunch of bad guys with guns, and they're roaming the streets, shooting their guns, and they get caught in a cul-de-sac. All of a sudden, they're pretty harmless, right? Because all they can do is shoot the stuff there, and once they've shot everything, there's nothing else to shoot, and so they become useless, mute. They become irrelevant. Yes, very good theory. Sir, that's not in this video. What are you talking about? I don't care. Have Rabner numberize it, and let's see where it goes, whatever this shit is. But sir, we funding? What the fuck are you talking about? Flunk funding? Have out people? What the hell are you talking about? Have our people get on it, and let's see before those damn Ruskies get their hands on it. Okay, you're just wasting time here, right? But sir, this Gary guy is a YouTube personality. You're just, I mean, really, you can't make an argument. This is the best you can do is defend your fableism with another fable. You can't ever put sentences together that can make any sense at all. You have an irrational perception of reality, and this is how you argue without making any counter arguments to the points that have been made. Oh, pathetic creatures. All right, still no comments from the asshole. Oh, I mean, the listeners. Yeah, the listeners aren't commenting. All right, so I guess I will go on a couple of subjects. So I want to do a gravity drawing. Yeah, I think it will require a drawing, I think. But there might be some other subject. I have to just check my notes here. Effect of charge. Mass independent. Okay, so this is sort of a tricky subject. So charge, they say like the proton and the electron have the same charge. And when they're measuring charge, they're measuring the effect. So like the gravity argument, the pull on me or this pen is exactly proportional to mass. So I will be pushed down by extra force, to make me feel the same amount of pressure total that this pen feels. So the pen is actually getting hit by less force because it's lighter, but it's exactly the same proportion of force to mass that I'm getting hit with. So we would both fall at the same speed, and we both would feel the same pressure. If it was a feeling organism, it would feel the same thing I'm feeling. And if we're moving through space, the same rules apply. To stay in orbit, the pen has to go exactly the same speed as I would have to go to stay in orbit. Our masses are irrelevant. The only thing that matters is our velocity. Charge is doing the same thing. So the fact that the proton is bigger means it creates more charge, but it's affected by charge exactly the same way the electron is, totally proportional to its mass. So when you're measuring its charge, you're measuring it being affected by charges. You can't do it any other way. The only way you can measure the charge of the proton is to put it next to another proton or to put it next to an electron. There's no other way to measure its charge. And so you're really just saying, how much does that gravity affect it? And so it's the same rule. It'll affect it exactly the same no matter what size it is. So charge, as you experience it, is fundamentally different than what creates charge. So the things creating charge They're creating it based on their mass. Size matters when you're creating charge. Size doesn't matter when you're having your charge measured. Okay, so like the sun, if the sun was going to go in orbit around the Earth, it would go exactly the same speed as the moon. It wouldn't have to go faster, even though it's gigantic. It wouldn't have to go faster. If we're eliminating obviously the gravity of the sun, we're just discounting that and just saying what's the actual pull on the Earth. So this is sort of an important feature of this, is to recognize the difference between charge being created, right, like gravity. It's created by the mass. The more mass, the more effect of gravity. The more everything proportionally feels more pressure. The more pressure being created, or absence of pressure in this case. And the smaller, and then when you're measuring it, it's only about what the thing is, of how the thing that's in a rigid position is affecting it. Yeah. And so I'll go a step further and explain how that's applicable to gravity. All right. So, yeah, I don't know if there's some other subject. I mean, they're all good. There's lots of little subjects here that were brought up by Bill Gates, in the sense you could just go on about energy or words, fields, force. I could do that, but I guess it would be better to do it in my, in the context of where I'm arguing these simple arguments that we should not speak of the speed of light. We should speak of the speed of force. Yeah, you only see my forehead. Cool. Yeah, that's enough, isn't it? Yeah. Yeah, I did have to move it for some reason. So yeah, anyway, that yeah. Yeah. You could have said that a lot earlier, but whatever. People aren't very useful, I have to say. The viewers have really gotten less and less interesting, sadly. Useful and interesting. All right. Anyway, where was I? All right. So yes, I'll switch cameras for the drawing fun. And I can't get to the camera, can I? No, I can't. It's a little bit irritating. I have to do this. Yeah, so no, that's not the right one. This should do it. All right, turn the camera off and then turn the camera on. Okay, that should do it. Take a moment. There it is. It didn't take a very long moment. Okay, so we don't need this, and we need pens. All right, so the interesting truth about gravity. All right, so you have the idea of this thing that's collecting little bits of mass. And the argument I've made sort of is that when we say there's this surface gravity, is 10 meters per second, in fact, that force is converted from gravity, so to speak, into chemical pressure. That is, the force goes all the way to the center, and that in the form of pressure. So the center of the Earth is under extreme pressure, and that's why it's liquid. And it's also being accelerated in all kinds of directions, so it's being torqued, which is also another reason why it turns into liquid. So it's really hot inside the center of these big objects. I mean, I bet the moon is hot inside. So anyway, but all right. So the idea is that gravity is created because you have the idea of, okay, so say I'm a little object and I'm going to become part of the Earth. And so the gravity, the argument being made essentially is that the Earth is going to absorb energy going this way. And in that sense, it's so let's say when something, let's start off with it, let's just say it's in one location. Just forget about this thing for now. So it's in one location. You can sort of get the idea that if the force is hitting it from all sides, that essentially, and it's equal from all sides, that the Earth would be going, the center of the Earth would be going a little bit this way, then go back this way, then go back this way, this way, this way, this way, this way. It would be doing all this kind of jittering, but it would always end up at the center at an average. So if there was exactly as much pressure pushes from all sides, or let's call them absorptions. It absorbs a little bit of extra energy this way, then it releases that energy and absorbs a little bit going this way. So it's always being tugged and pulled in these different directions. So it's always moving. Now the trick is, the argument is that when there's another body involved, that when this energy is absorbed in this direction, that is, it stays inside the object, trapped inside the object, that little piece of momentum in this direction has been consumed. And therefore, it doesn't hit this object. And because it doesn't hit this object, that means it got hit by more stuff going this way. And by hit, I mean it will absorb more stuff going this way than it will this way. So there's only 2 arrows going this way now, 3 arrows going this way. So it's going to absorb more force going this way than it will absorb force going that way. Clockwise, counterclockwise, however you want to look at it. It's going to absorb more energy this way than that way. And so it will move towards the other body because the other body absorbed that little piece of energy. Now the trick is, if this planet absorbs an extra arrow going this way, a little more than usual, and moves in this direction, this body won't know that. You'll never see that arrow because it already went through this one. So it's already been irrelevant. So the arrow that goes through this body or is admitted by this body never comes back to this body, technically, unless it reflects off the Earth. And some of it does, but let's not make the argument more complicated than it needs to be. We won't get into protons and electrons because they're really what's mitigating this. But the point is you can just see the net effect is it's obviously going to see when it doesn't receive an arrow going this way, that it'll see. It can't see whether this arrow went right through the Earth, missed the Earth, nothing. It won't see it. So if the Earth, so if this body absorbs the arrow and moves this direction, it won't see the effect of that except in the form of the fact that the distance is now increased, and by the inverse square law, as you get further away, distance means you get further away. That means the amount of force that can hit you gets less and less and less. So obviously, the connection between the two bodies is diminishing. So the gravity becomes less because more of the external. So if these two bodies get further apart, that means more of this external force gets to this object. So more of the force that was being blocked by this obviously gets to this object, so it feels a pressure in the opposite direction. But there's no direct connection in the sense that that inverse square amount of effect is much smaller than the direct effect of it felt the absorption in this direction, and it actually doesn't feel directly the absorption in this direction. So the arrow that doesn't get to it, it certainly feels. The arrow it sends away that gets absorbed, it doesn't feel it directly. It only feels it indirectly by the inverse square law, by this object moving further away, which means it has less gravitational effect. So that's why the Earth, or the sun, let's just say the sun, the sun, by having pressure, always pushing things towards the middle. All right, so there's a constant pressure towards the middle. That means that essentially this pressure, this direction, this body can't sense. So when the sun moves this way, it doesn't really feel it. But when the sun moves this way, it does feel it, because when it moves this way, it means it absorbed one of those arrows. So it absorbed an arrow to move this way. This body will feel it. When it absorbs an arrow going this way, it doesn't feel it directly. And that's why this body has gravity, is because when it's jiggling, the only part of the jiggle this body directly feels is the motion this way. It doesn't directly feel the motion this way. And so it's this asymmetry, okay, asim, between those two feelings, you know, the direct effect. The effect this way is indirect, the effect this way is direct. And that's why this body is creating a constant gravitational pull, is because when it moves, when it jiggles this way, it causes an effect. When it jiggles this way, this body doesn't really feel it. So one way it feels it, the other way it only indirectly learns of it eventually. So one is very direct, one is half as direct. So it's almost like just saying there's half as much force. So this force going this way, it feels a full 1F. And when it goes this way, it only gets half an F. So obviously there's a constant pull this way. All right, so it's probably enough. I mean, it's like I said, the real thing that's happening is always happening between the electrons and the protons. The subatomic bits of all atomic bodies are where gravity, where all the forces really happen. That's where the nuclear engines are. And that's what's really running everything, are nuclear engines. But this explains why you don't need the mass of this body in the understanding of the gravity caused by the sun. The sun really doesn't care. The Earth's only going to be part of the sun eventually as a gravity. Okay, it has meaning in this bigger arc of the solar mass. So if we include both these masses in one big arc, then you could say the Earth's mass is relevant. But the Earth's mass really isn't relevant to the fact that this body is constantly creating a lack of pressure going in, because no matter where I put an object, no matter where I put it, every object is going to feel that scenario where it feels the absence of the rock hitting it, but it doesn't feel the rocks it's throwing absorbed or being absorbed. So when the rocks it throws make the sun move, it doesn't directly feel that, where it directly feels the rocks that hit it. Something that obvious. All right. We already did this. We always see a forehead. We did that. Okay. Can a photon be made of one red force bit and one black force bit? Then it really wouldn't. I think logically there can be any number of red bits between, okay, the black bits. There can be red bits in the stream of electromagnetic radiation. So, but it's not relevant because it can't get to the protons. And the only part that matters to the electrons, let's say it again, are the reflecting bits. The reflecting bits are what makes electrons move. So that's the important bit. So I would argue that yes, there can be, but they wouldn't be 1-to-1, because then the frequency would be steady. The frequency is the distance between the bits. It's the empty space. The bits are just bits, and they're always the same size. Okay. retracted, a lot of retracted comments, kind of strange. Retractors. All right, so I've pretty much accomplished my task here, so I'll give you a little bit of time if you got anything to say. But I think I've done what I intended to do. So I do have new slits to work with and such. And so I'll be doing that, film slits, very precise and such. So, got to find the time and all that kind of crap, and I got to clean the porch and blah, blah, blah. But yes, I do intend to get to that soon. So that should be interesting. Try some variations on the theme and whatnot. Try to do some photographing of the periphery and see what kind of spread there is to the pattern, and demonstrate that it doesn't go nearly as far as it should be going. I think you can already know that, ironically, the evidence is already sort of obvious, is if you watch the double slit, or the single slit more specifically, as you make the slit wider. So when you use a variable width and you make the slit wider, the pattern gets smaller and narrower and narrower. The bars get more numerous and they start to contract. And it seems kind of obvious, okay, that they're not going all these places, that there isn't all the way to 90 degrees. It seems kind of obvious that that's really not happening. There are no photons going even 45 degrees. There's not even ones going 25 degrees. It's quite obviously collapsed the entire function. What percent of all force in our solar system comes from the sun, do you think? Well, obviously, by mass, the sun is enormous. So, I mean, it's like 1,000 to 1 in terms of, like, if you took all the other planets, they're like 1/100th maybe or something, the mass of the sun. I mean, it's much smaller total mass for all the planets. And what force do you mean? I mean, obviously the light in the solar system, the photons, the sun's producing 100% of that pretty much. The planets are only reflecting light. I don't think any of them are emitting any real signature. Now, they might have an infrared signature, so they're producing some photons, but it's a tiny amount compared to the sun. So Jupiter's a little bit warm. It's producing some infrared radiation, but compared to the nuclear energy being irradiated by the sun, I mean, you could take 1/1,000,000th of the sun's plasma, and it's producing more energy than all the other planets put together. So the energy, the light, the electromagnetic spectrum, the sun is producing 99.99999%. So there isn't a lot of force coming from outside of the solar system. So again, you said light, then you said not light. I mean, what are you talking about? Force isn't just photons. Force is magnetism and force is gravity. Do you understand that? They both move at the speed of light too. They're actual somethings. So obviously I'm arguing there's a lot of force outside of the solar system. That's why the solar system can be compressed, is because the external force exists. Oh, shit. The sun can't have gravity without the external pressure. The sun isn't producing. The sun is consuming. That's why the sun's on fire. The sun is really big, creates a huge amount of pressure in the center. Everything goes nuclear. And the sun is essentially, through creation of that pressure, is what's creating the gravity. The sun is consuming energy. That's why it's hot. It's not producing energy, technically. I mean, gravitational energy. It's consuming it. That's why the external pressure is being made obvious. We're seeing, gravity is you seeing the external pressure. You can't see the external pressure when something is equalizing it. You see it when something is putting low pressure below you. So we're on top of something that's consuming the pressure, so creating a low pressure, and now I can feel the high pressure above me because it's higher than the low pressure. Jeez. Okay, I thought the sun was producing photons. Well, of course it is producing photons, but photons are a tiny amount of energy compared to gravity. The amount of photons the sun is producing couldn't possibly push planets, to counteract gravity. That's why the planets have velocity. I mean, if the photons could do it, then the planets wouldn't have to have velocity. They have to have velocity because that's the only way they can prevent being sucked into the power of the gravity. The pressure would push them in if they didn't have velocity to keep trying to push them out. The sun's producing photons, but it's consuming more, whatever you want to call them, gravitons. It's consuming more external radiation than it's producing in photons. And such. Good answer. Thanks. Yes, well, they're all good answers, I think. 96.5% of them are good answers. Something like that. All right, hot as hell here still. Humid as hell is what the real problem is. I mean, it's only 85 in here, which isn't terrible, but it's 85% humidity. So my hair is a little bit nothing. Also fucks my eyesight up. My eyes don't like humidity. They seem to get gluier. Happen to be particular at this moment. They just went really bad. I mean, it's like, wow, maybe I'm having a stroke or something. Everything's getting fuzzy and dark. It's probably going to be that way. I probably will drop dead in a live room. Yeah, quite depressing. How does your explanation of atomic bombs differ from the one conventional physics? Well, you can't really argue it. It's kind of obvious that, I mean, the only thing that's different is there's no need to have orbiting electrons and all that kind of stuff. But obviously, protons and neutrons are locked together, and the electrons are more mobile and on the outside. And the idea is that these radioactive elements are vulnerable. You can knock one of their neutrons out, not just one. You can knock three of them out, actually. So you can shoot one neutron in and three neutrons pop out. And with it, a whole bunch of little electrons and other shit. So you're basically changing the atom. You're taking a big fat atom and you're creating two smaller atoms. And you're having all these leftover bits, 10 zillion electron volts worth of little bits. But the little bits are of key components. So it's not only like 15 electrons, but the key component, that's the start, that's the part creating the photons and all the electricity and all the blah, blah, blah. The pressure is being created by that bit. But the neutrons are the thing that sustain the chain reaction. Because by putting one in and getting three out, I mean, obviously, if you have enough density of material, that's why they have to do the heavy, that's why they have to refine the uranium and make it really, really pure, is so the atoms are close enough that you can guarantee the neutrons don't decompose before they hit another nucleus. So they need to hit another nucleus. And then when they hit another nucleus, they'll do the same thing. They'll break the atom into two pieces, create a bunch of energy, and create 3 more neutrons. So it's all about that chain reaction. So nothing in my physics finds that at all objectionable. I mean, that's perfectly reasonable theory. So yeah, it's all particles. It's all quite sensible. Except their explanation for the photons. They don't have any explanation for all the photons that the nuclear chain reaction creates, where my theory is, of course, you would understand where all the photons come from because they were trapped. They were the ping pong balls with the electrons. And when you expand the electrons to new locations that are way far away from the atom, obviously all these ping pong balls are going to be flying out all over the place. Very few of them are going to remain bouncing between those electrons because everything's getting expanded. And so not only do you have electrons moving pretty fast, but more importantly, you've released a ton of photons. And so the real power of the nuclear bomb is those photons. Those photons are the things that's going to burn everything. Everything's going to get incinerated. It's getting incinerated by a ton of gamma radiation and X-rays and infrared and ultraviolet and all these, a lot of ultraviolet, right? I mean, a ton of ultraviolet radiation being produced by the bomb. So the bomb's really just the thing that makes all the damage is the photons. The thing that makes the photons get released is the expansion of the electrons. And the thing that causes that is the disintegration of the nucleus, which creates 2 smaller charged bodies. And maybe some protons are flying around, but who cares? They can't do anything. So there's probably a proton or 2 that gets released, but it's irrelevant because the only thing that really matters is those neutrons, because the neutrons are the ones that'll blow up the other atoms. So I guess the simple answer is not very much. My explanation isn't that different than theirs, except I explain what a photon is. They don't. And I certainly can explain why knocking a neutron neutrons out of an atom are certainly going to cause irreparable damage to the nucleus. Well, I mean, they probably have some theory of that also. I mean, why the nucleus splits into 2, that somehow the nucleus tends to split along these lines. So it's like the nucleus is like a double brain, and you hit the brain and the 2 brains split off. So, that's a mechanical feature of the uranium atom. So in some sense, it has a location that's critical. And so the neutrons have to hit the critical location. It's like splitting a diamond. They have to hit the right spot. And if they hit the right spot, then it happens. If they hit some other spot, there's some heat created, but there's no big deal. Nothing breaks to pieces and the neutrons don't fly out. So it only has to hit the key spot. And that splits the atoms in 2. Splits the nucleus into 2. There probably is some other video I could play or some other thing. Let me think if there's anything else. Commenters are just kind of weak lately. Weak commenters. What the hell is this? It's spectral lines. You know, there's a whole bunch of stuff to talk about spectral lines. I want to get to that subject, but not today. So I did that. Where's my page of notes? Oh, here it is. Let's see. These are terrible notes. I really have to do better than this. Really have to work on my note taking. What the hell does that say? Cause versus effect. Well, that's a good subject, though. Yeah. Yep. Science is more than just effects, it's also causes. And physics doesn't do causes very well. They just make it up. And they make up silly shit. I mean, it's just Heisenberg. It's just silly. Again, you know, obviously there's a problem. Yes, everything's a little blurry. And, you know, you sort of have a 50-50 choice. You can say, oh, the universe is blurry by nature. It's a blurry verse. Or you can say, yeah, our eyesight kind of sucks. It just seems the logical answer is we can't see, not that the fucking particle doesn't have a location. It's stupid. All right, well, I guess I'll have to move on because you people are just not very engaging. However many of you are. I guess let's see, I should have a pool. All right, $4,000 to the first person who predicts how many people are watching this video. You know, I'm turning into a game show. You know, then maybe you'll play along. But I'm not going to do that. Fuck that. I predict 15, 17. We're lost. All right. So anyway, yeah. So I'll give you 2 minutes more. 2 minutes. Maybe I won't, but we'll see. All right. Looks like that's enough time. Yes. Gotta find somebody to talk to. So yes, if you're interested in having conversation, you can do the Bill Gates guy. If you can perform as well as his son or something in a physics conversation, and I'd appreciate the challenge to convince you in a personal way. Yeah. But of course, you have to come to the table with some knowledge of physics. You know, something. You know, you can't just be a neophyte thingy. I mean, you can't ask too stupid of questions. Well, I suppose you could. I guess it doesn't matter. But anyway, so if you're reasonably literate and can engage in civil-ish conversation, email me at ds@draftphysics.com and such. And you have to have the technology to get in this room, of course. So you need to have a camera or a microphone at least. You have to have a microphone anyway. Getting in the room is pretty simple, so you really should be able to do that. I mean, you just click on the link, and if you're using Chrome, it usually just loads all the software and does everything. You don't have to do anything. Just have to have your microphone set as your default. And if you don't, then you might have to check the settings, but that's about it. It's pretty simple. All right, so nothing from the gallery. Pretty disappointing, but I have been disappointed in life, so I'll likely get over it. Yeah, that's what I do. I'll likely get over it. And such. So till the next time, and we'll just keep moving along, and that's about it. So I will have to do some subject videos, some more subject videos, nail all this stuff down, but it's all good stuff. I mean, every day I think it's something. It's, just gets better and better and better. And but the bad news is it all becomes more and more obvious to me, and I'm just sitting here saying, how can you people not get this? Push, pull, I mean, it's obvious. Speed of force, speed versus speed of light, obvious. Traps, oh, fucking obvious. It's all so fucking obvious. Damn. All right, so till the next time and such. Fuckers. Useless.